We're going to start the next unit looking at functional relationships, and hopefully you have OneNote open. You've got copies of these notes, so let's get started. First of all, what is a function? A function is a relationship between two variables where one value depends upon the other. A functional relationship is one-to-one. For one value of x, there's only one value for y. A non-functional relationship for one value of x, there may be several values for y. For a linear functional relationship, the graph is going to be a nice straight line. If it's a non-linear relationship, the graph is going to be some kind of a curve. We should be able to identify a function in 4 different ways. If we're given a table of values, say the x's are 2, 3, -4, -1, the corresponding y's are 7, 9, 8, 0. Notice how each x value has only one y value. What you're looking for in a table of values here is whether or not that same value of x repeats. In this case, our table only has 4 x values, and they're different x values each time, so this would qualify as a function. As far as a graph is concerned, if our graph looks like a nice line, that qualifies as a function. If it's any kind of a curve, it does not. What we're going to look at here is something called the vertical line test. If we draw a vertical line anywhere, how many times does it hit the graph? Well, if we draw a vertical line so it just hits the line part of it here, it's only going to hit once. So we can say that it passes the vertical line test. Whereas this curve down here, if I put in a vertical line, it hits twice. That fails the vertical line test. It's not considered to be a function. We can tell that a equation is a function if it has a y variable in it that's only to the first power. For example, we could have y is equal to 3x plus 7. That's a linear function. It has a y variable and it's only to the first. We could have y is equal to 2x squared. Now, the square on the x doesn't matter as long as the y variable is only to the first. We could have y equals 8, where there is no x variable at all, but we have a y, it's to the first power. And then finally, we should be able to identify a function from ordered pairs. Say we were given 7, 4, negative 2, 9, 13, 6, 0, 2, 8, 8. We're going to look at those ordered pairs of values and see if the x coordinate is repeated. So ordered pairs and tables are very similar in that we're going to be looking for x values, looking for repeats, but it's just going to be written in a different format. When talking about functions, there are two really important terms you need to know that will describe those functions: the domain and the range. The domain is the set of all possible values for x. The range is the set of all possible values for y. Now again, if you can remember to put domain and range in alphabetical order, then their definitions are in alphabetical order. If we are given a table of values, the domain is simply a listing of all of the x values. Now, sometimes we need to rearrange things. It's always a good practice to arrange them from lowest to highest. So our domain in this case are just the numbers -3, +2, 5, and 7. For the range, We don't have to worry about keeping them in order. It's just the set of all possible values for y. So in this case, the smallest value is -12, then 6, then 9, then 11. If you are given a graph, the domain and range sometimes get a little bit tricky because the graph is never going to be infinite. So we need to pay attention to, hey, look, you've seen this before with graphs of lines. How far does the graph go to the left and the right is something you'd look for as far as the domain is concerned. Again, it's all the possible x values. Well, in this case, because it has the arrows going off to the left and to the right, the domain is all real numbers. As far as the range, you're going to look at how far up or down the graph goes. Again, for a line, it's all real numbers. We'll come back to this later when we start looking at different kinds of curves, because the range is going to change. If we are given simply a list of ordered pairs, very similar to what we did with the table, we're simply going to, for the domain, list all of just the x coordinates. So in this case, -4, -1, 2, and 4. The range is going to be the list of just the y coordinates. -3, 0, 6, 7. Let's take a look at some practice problems here. Classify each relationship as a function or not a function. Identify the domain and range. If it is a function, tell whether or not it's linear. So for our function for number 1, the points, we have ordered pairs, 3, 2, -1, 5, 7, 3, and 2, -3. For the domain, it's, well, if we put them again, smallest to largest, -1 is the smallest, then 2, then 3, then 7. There are no repeat values of x, so we can say, yes, this is a function. And then the range, again, is simply a list of the y coordinates here. So we have -3, +2, 3, and 5. For number 2, given a table of values, is this a function? So again, looking at the x's, we don't have anything repeated, so yes, it is. The domain, I guess the smallest value for x is -3, -1, +1, 5. For the range, -5, 0, 2, 6. For number 3, classify this as a function or not a function. Hold on. I can see a place where I put in a vertical line and it hits the graph 1, 2, 3 times. If the graph shows us a function, a vertical line, no matter where we put it, will hit the graph only once. In this case, this is no, not a function. This is just a nice way of reminding you. We should be able to identify functions by looking at a table of values by looking at a graph, by reading an equation, or from looking at ordered pairs. Now let's talk a little bit more about that vertical line test. If you can draw a vertical line that crosses the graph in more than one place, it's not a function. So for this example, nope. That fails the vertical line test. It is not a function. We're going to compare input and output. Now again, all of the tables that you've seen so far are horizontal. We could just as easily put them vertically here. We're looking for one value of x has only one value for y. Again, this is not a function because right here, for the value when x equals 3, we get two different values for y. When you're given an equation such as y squared equals 4, try and solve the equation for y. If we're able to solve that for one value, then it is a function. In this case, hold on. If I substitute 2 in place of y, 2 squared, 2 times 2 is 4. But if I substitute negative 2 in place of y, negative 2 times negative 2 is also positive 4. This, again, is not a function. Sorry, let me zoom in a little bit on this, and let's talk about classify each relationship as a function, not a function, domain and range. If it is a function, state whether or not it's linear. For number 1, this is not a function. If I put in a vertical line here, yeah, it hits only once. Put in a vertical line here, it hits only once. But if I put in this vertical line here, oh my goodness, it hits way too often. But let's still talk about the domain once I get my vertical lines out of the way here. Notice here the domain has a low value of -4 and it stops at 7. So this is sometimes referred to as interval notation. Now notice you put the little fancy curvy bracket things around it there rather than just curved parentheses. We don't want anybody confusing this with coordinates of a point. What's the range? Again, range, think about how high up the graph goes, how low does it go, and here and there indicating it doesn't stop. So the range of y coordinates on this graph is all real numbers. For number 2, this is a function. But it's not linear. It is a function because, again, no matter where I put a vertical line, it only hits the graph at one location. So that's why it is a function, but hopefully fairly clearly we can tell Yeah, that's a curve. That's not linear. So let's talk about domain. How far does it go left and right? Again, with the arrows. It's all real numbers. How far up and down does it go? The range is, again, all real numbers. Number 3, looking at our diagram here of domain and range. Well, okay, the domain, that's pretty easy. Now, again, if we want to put that in the proper order, the domain's going to be 1, 2, 3, 4. The range just has one value of -4. That was pretty easy. But notice what happens right here. We can get the same value in the range over and over and over again. Ooh, now hold on, that's kind of tricky. For one value of the domain, we got, it looks like two different arrows, but this still qualifies as a function. Now, if this said -4 and that said -3, then it would not be a function. Didn't do that. They give us, no matter what the x value is, the y value is going to be -4 every time. This is a line. Now compare number 3 to number 4, where we have the point 1, -2, and we also have the point 1, -3. This is not a function. For one value of x, specifically +1, we got two different values for y. We could still write out the domain as -2, -1, 1, and our range here is -3, -2, 0, 2. For example 5, yes, it is a function. For every value for x, you only get one value for y. And again, writing out domain and range should be fairly simple. For number 6, again, take a look at the table. Yes, this is also a function. And again, I would think that writing out domain and range for those are rather straightforward. Wait a minute. Hopefully you caught that. Look carefully. All right. This last part here, I think, is simply how good are you with substituting and then following order of operations. Evaluate each function using the given values. Notice it does say show your work. So we're looking at here's f of x, here's g of x, and here's h of x. This is something that we simply call function notation. It denotes the difference between one function and another when we use f or g or h or k or whatever letter we so choose. So it allows us here to find f of 2 and g of 2 and h of 2. That'll tell us where to substitute. Inside the parentheses, that tells us. So for number 1, when we're looking at f of -8, that means we're going to take -8 and substitute that everywhere there's an x. So if negative x over 2 and x is negative 8, this means negative 8 over 2. That's negative 4. But the negative of negative 4 is positive 4. That value is then 5. Coming down to number 2, f of 2, that means we're going to take negative 2 over 2 plus 1. Well, now that I've substituted a positive, positive divided by a positive is 1. Change the sign on that. Negative 1 plus 1 is 0. Now for number 3, we're switching to a different function. This is f of, no, it's g of 5. So that means we're going to take 5 and substitute it not into the f of x function, but into the g of x function. So this says x cubed minus 3, so that now means 5 cubed minus 3. Now again, if you want to reach for your calculator here, 5 times 5 times 5 is 125. 125 minus 3 will knock that down to 122. G of negative 2 means we're going to take negative 2 cubed and then subtract 3. Again, cubing a number, raising it to the third power means multiplying it by itself 3 times. Negative 2 times negative 2 times negative 2, that's an odd number of negatives. 2 times 2 is 4, times 2 is 8. So negative 2 to the third is negative 8. And then subtract 3 from that. That gives us negative 11. And then for number 5, h of negative 6 means we're going to take 4 divided by negative 6 minus 4. You're going to substitute that number anywhere, everywhere that x variable is. So in this case, positive divided by negative is negative. We'll reduce that down to 2/3 minus 4. We could write that as 4 over 1, since it's an integer. And then combining, we need common denominators, so that would be 3. So 1 times 3 is 3, 4 times 3 is 12. So it's taking negative 2/3 and adding a negative 12/3, that'll be negative 14/3. For example 6 here, h of 2 means we're going to take 4 divided by 2 and subtract 4. Well, this is much easier. 4 divided by 2 is 2. 2 minus 4 is negative 2. And then they might just switch things up on you. Now, in this case, if f of m is negative 14m, find f of 2. So that simply means for f of 2, we're going to take negative 14 times 2. That should be negative 28. Every single time here, you're simply going to substitute. Say we pop on down here to number 11, find the value for which g of x is equal to 48. If g of x equals x squared plus 8x, oh, wait a minute, they've changed things up. They're not telling us that the 48 is the value for x. They're telling us what the whole thing is equal to. So in this case, that means x squared plus 8x is equal to 48. Gee, I wonder what we're going to do for that.